All right, so just to review the problem, angle of elevation, we're starting here, we have a tree, we don't know how high the tree is, so we gave that a y. We know the angle of elevation is 37 degrees, 27 minutes, and we're 40 meters from the tree. We walk a distance of x, we don't know what that distance is, but at the new point, we have a new angle of elevation to the top of the tree, 51 degrees, 42 minutes. Broke down this situation into two right triangles. The first one is our original, which was 40 meters away. That was our 37 degrees, 27 minutes. And then drew a second right triangle for our second situation. When we stopped after we walked, we have a new angle of elevation to the top of the tree, 51 degrees, 42 minutes. But we are now 40 meters minus x from the tree because we walked a distance of x, so we have to take that off of the total distance that we were from the tree at the start. This is extremely typical of any type of angle of elevation or depression problem that you're going to get. Setup, and I know we had a little bit of work. You can look at the other recording to kind of see how we go through it. But the angle, the only two sides that we know are the opposite and the adjacent. We don't know the hypotenuse of this right triangle, so works out pretty good for us. We build a tangent because you always check, since it's a right triangle, you're always going to want to do right triangle trig. SOHCAHTOA is your guide for that. So TOA for tangent, we know an opposite, which is the tree. We know the adjacent side, which is the distance on the ground. So we can build the tangent of that 37 degrees, 27 minutes is the opposite side, which is y over 40. And here, same thing, tangent of 51 degrees, 42 minutes is y over 40 minus x. The unifying variable, or the connecting variable with these two equations that we can actually connect them to solve it, are the y's, the height of the tree. That doesn't change. Everything else is changing. The angle of elevation changes, the distance changes, but the height of the tree never changes. So when you're dealing with a story problem in multiple situations, there's going to be some condition that doesn't change. That's your connector between all the different equations. Solving both for y, we did that. We have to multiply by 40 here and multiply by 40 minus x here. We got our equations. We can connect them because the y's are exactly the same. Those are the heights of that single tree. We did that. Solved for x by dividing the tangent of 51 degrees 42 minutes from both sides. And remember, I just wrote 51 degrees for quickness, but we have to use that angle at the end. So now we have 40 minus x equals 40 times the tangent of 37 over the tangent of 51. Divide by 40. So we get this equation in black here. Multiply by a negative 1 because we want x and we don't want negative x, so it just flips it. And so we have 40 minus 40 times the tangent of 31 degrees 27 minutes over 51 degrees 42 minutes. Now, when we were in session and I did that, it ended up, the big problem was I was in radian mode in the calculator. And if you remember, the answer came up to be 77, which doesn't make any sense because if we're starting 40 meters from the tree, we can't walk 77 meters. We'd go right past the tree. So to me, right away, that number didn't look right. And I wasn't exactly sure why, but kind of examining things, I had thought we had put things in degree mode, but I guess I didn't hit the enter key. So always check that when you're doing a problem like this, that you're going to be in degree mode when you're dealing with real life angles, because those are most often going to be in degrees. So make sure you're there. If not, you can be in radian mode and it'll work. And I'll show you how to do that in a second. So let me go through here and kind of, let me do insert. That's 37, or 37.27, so point. Or actually, here's what we need to do. Let me start from the beginning. Here's the key that you need, where it says apps. Above the apps in blue is angle. If you hit second and then hit the apps key, there's your degree, there's your minutes. We're going to need these when we're creating the equation for this. So here's the equation that we want. So first part's easy, 40 minus. Now I'm going to open it up because I'm going to subtract off a fraction. And now I'm going to open up a new group for the numerator. It's going to be 40 times the tangent. Now I want to make sure that they know it's 37 degrees. So 37. And now I need the degree symbol. And that's in the apps. So we're going to hit second apps where it says angle above the top. And number 1 is the degree symbol. So I'll type that in there, 37 degrees. Now I want 27, go back into angle, and I want the minutes key, which is 2. And then close that because now that's the top. Divide by the bottom. So I need to open up the group for the tangent, and I need 51 degrees, so 51, and then second angle. That'll give me the degree symbol, so 51 degrees. Now 42 minutes, second angle. Then I go down to 2. There it is. So there's the numerator, or the denominator rather. I'm going to close that. Now my answer is 15.8. So that tells me that my x is about going to be 15.8 meters. If we go back to our picture, what that means is we have walked from here to here, 15.8 meters. And another question they can ask is, how far away from the tree are you? All you have to do is take 40, which was the original distance. I'm going to subtract off the answer. You could have wrote 15.8. And so now this is just going to be 24.2 meters. And so now we can kind of see what these distances actually are. So the big key to this is SOHCAHTOA when you're dealing with right angles. When you're building angles in minutes and even seconds, you're going to have to kind of do it the old-fashioned way like this. The nice thing is, clear this out, if I go to radians,